In this video, we're going to be talking about z-scores. The z-score of a value in a sample is the number of standard deviations the value is away from the mean. Z-scores can be used to compare values from different samples of data. The formula that we have to calculate z-score is if we're working with sample data and we have a sample mean, sample standard deviation, is the z-score is equal to x, where that's your data value, minus the sample mean, divided by the sample standard deviation. If we're working with population mean, population standard deviation, we would use essentially the same formula, except we have mu and sigma here written instead of x bar and sx. Now let's look at an example. Suppose a sample of tree heights has a sample mean of 14 feet and sample standard deviation of 4 feet. Find z-scores for the following values. First, we'll write down our formula over here just to keep track of it. And then we'll plug in what's necessary and find our z-scores. For part A, we want to figure out what the z-score is for 18 feet. So we know z is equal to 18 is our x in this case. We were told our mean is 14, so that's x bar. So 18 minus 14 over the standard deviation, which we're told is 4. So this becomes 4 over 4, which is equal to 1. What this tells us is that 18 is 1 standard deviation above the mean, and it is. If we add 1 standard deviation, which is 4 to 14, we end up with 18, which is the value we get here. For part B, we want to find the z-score for 6 feet. So we'll start plugging values in here. Our x in this case is 6. Our mean is still 14. Our standard deviation is still 4. We end up with negative 8 over 4, which is equal to negative 2. Z-scores can be negative. If we have a negative z-score, that just means that whatever value we have is below the mean. And 6 is below the mean. Our mean is 14. 6 is less than 14, so it's below the mean, and we would expect to get a negative z-score. In fact, if you have a value that you know is less than the mean, and you try to find the z-score and you get something positive, that's one way you can know you made a mistake, because if you have a value that's below the mean, z-score is always going to be negative. If you have a value like 18 that's above the mean here, it will always have a positive z-score. So for parts C and D, I would suggest pausing the video, try to work on them on your own, then hit play to see me go through the answers. So for part C, we can plug everything into our formula. Here in this case, x is 14, but our mean is also equal to 14. So we end up with 0 over 4 and get a z-score of 0. Now this makes sense because 14 feet is the mean. So if we want to ask ourselves how far away is the mean from itself, it's not above or below itself because it is itself, so it's 0 away from itself. So the z-score of a mean itself will always be equal to 0. For part D, we have 8 feet. 8 is below the mean of 14, so we would expect whatever z-score we get here to be negative, but we'll plug it into the formula just to be sure. So we have 8 minus 14 over 4, or 8 minus the mean divided by the standard deviation. We end up with negative 6 over 4 is equal to negative 1.5. And generally for z-scores, we would round to 2 decimal places. In this example, we didn't need to round any to 2 decimal places, but there may be other examples. And if you do need to round 2 decimal places, is how far you should take it. Now let's look at an interesting application problem for this, because we can use z-scores to compare different sets of data or data points from different sets of data. So let's say Virgil got 61 on an exam where the class average was 51 and the standard deviation was 4. So we'll write this information down. Virgil got a 61, our class average was 51, and the standard deviation was 4. Next, we're told Dante got 75 on an exam where the class average was 70 and the standard deviation was 5. So we'll make a note of that information. Dante's grade was 75, the average was 70, and the standard deviation was 5. Now we're being asked who had the better exam performance. So we might say, well, obviously Dante did better because 75 is better than 61, but we have to take into consideration what the class averages and standard deviations were. If the class average is a 50 and you get 100, that's a better performance than if the class average is a 90 and you got 100, because if you get a grade of 100 and the average was 50, you're much higher above the average than you are if you got 100 on an exam where the class average is 90. So just because we see a grade of 75 here doesn't necessarily mean that's better comparatively when we put these two sets of data against each other. The way to compare these two grades is to find z-scores for each of them and to see who has the higher z-score, because the higher z-score will be higher above the mean. So first we'll find the z-score for Virgil, so that's going to be 61 will be x here, which is his grade, minus the mean of 51, divided by the standard deviation of 4. We end up with 10 over 4, or 2.5. So his grade is 2.5 standard deviations above the mean. Now we'll find the z-score for Dante. His grade was 75. The average was 70, divided by the standard deviation of 5. Here we get 5 over 5, which is equal to 1. So here we would say Virgil had the better exam performance because his z-score is higher, meaning the grade he got is more standard deviations above the mean. Now let's look at another example. This is the same type of application problem. I would suggest pausing the video here, try to work through it on your own, then hit play to see me go through the solution. So here we're going to suppose Chad got a 63 on an exam where the class average was 70 and the standard deviation was 3. So first we'll make a note of that. Next we're told Stacy got a 61 on the exam where the class average was 65 and the standard deviation was 5. So we'll make a note of that information. Now we want to figure out who had the better exam performance. We'll treat this the same way as the last example. We need to find the z-score for both grades and then see which z-score is higher. Now one thing we might notice is that both of these grades are below the class averages. So they're both, not good grades, but one of them is probably fewer standard deviations below the class average than the other one is, and that'll be our better grade. So first we'll find our z-score here. So our x in this problem will be 63. Our mean is 70. And our standard deviation is 3. And we end up getting a z-score here of negative 2.333 forever, but we round off to 2 places, so it's negative 2.33. Now to find our other z-score, our x in this case will be 61. Our mean is 65. Our standard deviation is 5. And we get a z-score of negative 0.8. So negative 0.8 is actually greater than negative 2.33. If we were to draw out a number line like this, and we have 0, and we have negative 1, and we have negative 2, negative 2.33 is going to fall somewhere around here. Negative 0.8 is going to fall somewhere around here. So even though we might think sometimes 2.33 is larger, when we have a negative number, if the value appears to be larger, that just means it's further away from 0, so it's actually a smaller number. So here we would say Stacy had the better exam performance because she had the higher z-score. Now we have one more example where we'll be looking at some backwards problems. In backwards problems, we're going to be told what the mean and standard deviation are, and then we're going to be given z-scores, and we're going to have to go backwards and find values or grades that they correspond to. So in this example, suppose it is known that the mean equals 30 and standard deviation equals 2 for a given population of grades on a test. What grades do the following z-scores correspond to? We're being given z-scores. We have the mean, we have the standard deviation, but we need to instead solve for x, or grades in this case. So we're going to solve these problems the same way we solved the first set of 4 examples we saw like this. There's just going to be a little bit more algebra involved because here we're going to be solving for x instead of plugging everything in and getting z. So for part A, first thing we'll do is take -2, put that in for z. So we have -2 is equal to x, which we don't know, minus the mean of 30, divided by standard deviation of 2. So the first thing we want to do is get rid of this division by 2, so we would multiply both sides by 2. So now we have -4 is equal to x minus 30. We'd add 30 to both sides, and we end up with x is equal to 26. But here I would suggest pausing the video, take a few minutes to try and go through the other 3 parts on your own, then hit play to see me go through the rest of the answers. For B, here we're being told 1 is equal to z, so we're going to plug that into our z-score formula. 1 is equal to x, which we want to solve for, minus a mean of 30 that was given to us, divided by a standard deviation of 2. We want to get rid of this division by 2, so we multiply both sides by 2. We get 2 is equal to x minus 30. Add 30 to both sides, and we end up with x is equal to 32. Now for part C, we're being told 0 is equal to z. So we'll plug all of this into our formula. 0 is equal to x minus 30 divided by 2, our mean and standard deviation. Same thing, we want to get rid of the division by 2, so we multiply both sides by the denominator. 2 times 0 is 0, so 0 is equal to x minus 30. We add 30 to both sides, and we get x is equal to 30. Which makes sense, because if we remember from one of the last examples, the z-score of the mean is always going to be 0, and our mean in this case is 30. Now here we have 0.25 is equal to z, so we'll plug that into our formula. We'd multiply both sides by 2. So 2 times 0.25 is 0.5, so we have 0.5 or 1/2 is now equal to x minus 30. We add 30 to both sides, and we end up getting x is equal to 30.5. The one thing I'll say about these problems, when you need to find the z-score, you will always be given the mean, and you will always be given the standard deviation. You'll either have to solve for z or for x, depending on what other information the problem gives you. If it's worded in a way where they're saying what grade or what other aspect of the data do the following z-scores correspond to, it means you're being given a z-score. If they ask you to find a z-score, then it's like the first couple of examples we saw.